And we are live. So, welcome everyone to Climate Chat. I'm your host, Dan Miller, and today we have a special guest from my alma mater, Cornell University, Dan Visioni, who is a
Hello.
climate scientist that works on solar radiation management, sunlight reflection methods, solar geoengineering. There's a lot of different names for the same thing. And Dan, first of all, welcome. And why don't
Thank
you
you.
start off by giving us a little bit of your background? What did you study? How did you get to Cornell? And what is your particular area of research?
Yeah, so I'm a climate scientist, I guess, by now. My PhD was in atmospheric physics and chemistry back in Italy. That's where I did my PhD, mostly looking at the impacts of volcanic eruptions on climate and atmospheric composition. Already during my PhD, that was during the Paris Agreement years, and so I felt like I wanted to do something that was a little bit more policy relevant in a way. And my advisor at the time told me, "Why don't you go to this meeting of these weird people that are talking about geoengineering?" And I went to the first meeting. That's the Geoengineering Model Intercomparison Project, which I now have the luck to chair. And yeah, I have been doing that ever since. In 2016, I met my previous boss, Doug MacMartin, who's also at Cornell, at a
Mhm.
meeting, and he said, "Why don't you come do a postdoc with me once you're done?" And I said yes, and I've been at Cornell ever since. So now I've been going 6 years to the day. Yeah, the end of October is when I moved to Cornell 6 years ago. Yeah, so now I'm assistant professor there. I am mostly a climate modeler. I collaborate. I work with ANCAR, with the National Center for Atmospheric Research. I'm one of the co-chairs of the Community or System Models. And I chair this geoengineering model intercomparison project. I do a lot of work with climate modeling of SRM, also climate modeling of ozone recovery and volcanoes, but most of my work is focused on SRM.
Well, that's great. And you mentioned Doug MacMartin from Cornell.
Mm-hmm.
We did an interview with him. The link is, by the way, in the description for the YouTube description. So folks who want to listen to that, you can find that there. And we also interviewed David Keith on the same subject or a bunch of subjects, including this, and the link is there as well for that. Well, I want to start off by just saying, just to set the stage for anyone who's listening, who's not familiar with solar geoengineering. These are techniques to artificially cool the Earth to counteract the effects of global warming. There's a lot of different ways of doing it. Usually we're focused on putting sulfur particles in the stratosphere, and your original work was on volcanoes. So why don't you start off by telling us why there is high confidence that we think putting sulfur particles in the stratosphere will actually cool the Earth? But how do we know this is all going to work?
Mm-hmm. Yeah, so I'll start off by saying that actually, so the in the 20th century there were at least 4 or 5 volcanic eruptions. They were big enough and reached the stratosphere, and they were sulfur rich enough that they affected climate. Um, how exactly? I think we always had a fairly good idea. When Pinatubo happened, the largest one was in 1991. There was Mount Pinatubo in the Philippines, and right after that, Jim Hansen wrote in one of the first papers about Pinatubo that our understanding of the fact that Pinatubo was going to cool the climate was one of the first tests of the goodness of climate models, right? The fact that in climate
Mm.
models, they predicted that the climate was going to cool, and indeed it did, was he called it sort of a first test of how well climate models could reproduce climate, considering that at the time the emergence of the signal of climate change in observation was still quite blurry. The fact that volcanic eruptions all at once, an eruption like Pinatubo threw 20 million tons of sulfate in the stratosphere in around 6 to 12 hours. That's a lot. It's not a lot compared to how much sulfate we put from the surface through many activities, but it's a lot compared to the amount that is in the stratosphere. And so these particles immediately turn into aerosols pretty quickly in a month. And then what makes them so good at cooling is the fact that in the stratosphere, there aren't that many removal processes. There are no clouds,
Mm.
there's no rain. And so the only thing that can remove the particles is either gravitational settling. The particles have a mass, and so they get pulled down, but that's very slow. Or large-scale circulation, mostly. And so while if you put a sulfate aerosol in the troposphere, close to where we live, after a week it will be gone, mostly through rain out. In the stratosphere, a particle will live for 12 to 18 months. So the combination of the fact that these particles are there, they're there for long, even though not forever, and they're well above clouds. So they reflect a part of the incoming solar radiation, and that cools the planet. That is, in terms of robustness of understanding, I would say that the same physical principles that tell us that CO2 warms the planet by affecting the energy balance on one hand. We also know that reflecting solar radiation, increasing planetary albedo, we could say, cools the planet, or at least affects the energy balance on the opposite side of what happens through increased opacity of the atmosphere due to increased greenhouse gases.
Okay. And so you said a couple important things there, including the fact that we are currently putting lots of sulfur in the lower atmosphere by coal plants and ships and other industrial processes. But as you said, that rains out very quickly, like in a week. But if we do it on purpose, and we're breathing it in, it helps to lead to the deaths of 8 million people a year. And so it's really bad. But when we put it up in the stratosphere, we put much less of it up there, and it lasts for a year to 18 months. So we get a far more effective, well,
you get more bang for your bucks.
Bang for your buck, and it's healthier too. It's healthier for humans because you're not killing as many people. Actually, David Keefe, I would said it's 1,000 times safer when put in the stratosphere than when done the way we're doing it accidentally on the Earth, which I thought was a very interesting point. But so, okay, so we can cool the Earth. That sounds like a great idea. You know, boy, global warming is making us hotter. It's increasing hurricanes, floods, droughts. We had Daniel Swain on last week telling us about all the extreme weather this is causing. So but we're not running out to do it right away. There's concerns. Can you tell us what some of those concerns, some of the known and potentially unknown side effects of doing this?
Yeah. So, well, yes, we're totally not doing it, except unless you account for a couple of small startups here and there,
which we interviewed a month ago.
Right. So I would say let's start with the fact that it is clearly so. Solar geoengineering (SRM) is not a time machine. It doesn't revert the climate back to what it was without climate change. If we take the global planetary view, as in fluxes in, fluxes out, we can imagine that it would cancel out perfectly the radiative effect of CO2. It doesn't, for a lot of reasons. So this is, again, purely from the physical perspective. We can say that, well, long wave flux, this is the planetary radiation that is affected by greenhouse gases, acts sort of from the bottom up because it's the planet that is releasing these long wave radiation, while the sulfate would cool sort of from the top down because it's reducing the amount of incoming sunlight. These affects vertical energy fluxes. It affects the way precipitation will be distributed. So it's not a perfect magic wand that would just bring things back to the way they were before. Of course, it also wouldn't affect all of the things that are actually affected by CO2 that are not global temperature. So, for instance, ocean acidification. So the first observation is, well, it's not a time machine, and that is an absolutely fair one. But I don't think that anyone opposes geoengineering on exactly those grounds, as in, well, yeah, nothing we do is perfect, right? The humanity is a rush to fixing other problems with other solutions that might further down produce other problems, right? And one can make the examples of things like CFCs, chlorofluorocarbons. We removed them because we knew they were damaging for the ozone hole. We moved to HCFCs or HFCs, that turned out to be large greenhouse gases. But on the other hand, we needed a quick solution to the ozone hole, and removing CFCs was one. And now the Kigali Amendment is taking care of HCFCs. So It is not a perfect solution. It is pretty imperfect. When we also talked about the climatic impacts, we and I mean climate scientists sometimes sort of imply that the way SRM would be done would be in a intelligent, smart, globally agreed upon way where the cooling would be uniform. That is, I would not say that that's not a possibility, but it's just only one of the things that could happen. So another one of the concerns is, what if a country or a group of countries just did that in a bad way? So maybe we know there's a lot of things that we can understand better and where we can sort of narrow down the uncertainty. But one thing we understand for sure is that if we cool the planet uniformly by having a layer of aerosol uniformly, we would reduce many of the impacts of climate change. We would reduce extreme events. Our climate modeling, pretty robust results out of climate modeling do point to the fact that many extreme kind of weather events would be reduced compared to a future where we don't do that. But we also understand very well that if one were to cool one hemisphere more than the other, that would screw up other things. For instance, the way in which energy fluxes are moved between the hemisphere. If you cool one hemisphere more than the other, that hemisphere will also try to get energy from the other one that is warmer, and that tends to shift tropical precipitation. So we know that if you cool an hemisphere more than the other, so if you do SRM only in one hemisphere, that is going to have potential very harmful effect on precipitation, especially in the tropical belt, which is where many people live and where much food is produced. So that is another kind of the concerns, I would say. The potential weaponization of militarization of geoengineering for purposes that are beyond managing climate change. People are concerned about other potential side effects for sure. One of them could be if you put stuff in the stratosphere, it affects stratospheric composition, and in particular ozone, which again, we were so careful with in the Montreal Protocol. In 2022, there was a ozone assessment. There's a quadrennial ozone assessment. And for the first time in 2022, the Montreal parties actually demanded a chapter on SRM. I was one of the authors with Simone Tilms and Jim Haywood. So we did a lot of work trying to understand what exactly would happen. There's a lot of modeling that was done in the last few years for that. Surely, we know that, for instance, adding aerosols to the stratosphere, these aerosols eventually would move towards the pole. And having more aerosols close to the Arctic and the Antarctic would lead to more ozone depletion. So these would sort of balance out the ozone recovery that we're currently observing because CFCs are going down. So our best estimate at the moment is that essentially if one were to do SAI now or in the next 10, 20 years, these would set us back and bring stratospheric ozone levels over the poles at 1990 levels. So it's sort of where the ozone was roughly at its worst. Okay. However, as you move on and CFCs keep decreasing, this effect would sort of go away. And then we expect that if one were to start later or just wait a bit, eventually ozone would recover anyway, because it's CFCs fundamentally that destroys ozone. So there are many of these examples one could make. I would say that if one looks at only physical impacts over the board for most of the things that we think matter when it comes to climate change, SRM is not as impactful as not doing SRM in terms of climatic changes. Now, the last thing is that, of course, I think that most people that are worried about SRM, in a way, I would say even completely fairly, are not worried about any actual physical impacts or risks. And even when it comes to, let's say, what people call unknown unknowns, I would be pretty prepared to argue that volcanic eruptions gave us a pretty good upper bound about how bad things can get after you dump a lot of sulfate all at once, and that's not what we're planning to do anyway. So the real unknown unknowns are not sitting in the physical realm, but in the societal one. How would societies perceive this idea of SRM? How would they respond? How would international relationships be affected by the idea of SRM? People make the example of moral hazard, which is not something I agree with, but it's a concern for many people, which is to say, if we do something like SRM, or in many cases, people say if we talk about SRM, do we convince people that they don't need to worry about climate change, and so they will not be particularly convinced to mitigate anymore? And then this would lead to more CO2 emissions. It would lead to worse impacts. But other people might be concerned. What if only strong bullying countries were to deploy SRM? What would countries in the tropical belt have a voice? Would African countries or South American or Asian countries be able to have their say? When we think about safety, are we using metrics that include different worldviews than just the ones of the scientists in Europe or in the United States? So there's a lot of concern that sort of are at the interface between the physical and societal world. Would we observe a weather extreme like the hurricane that just happened and say, oh, would people say, oh, this was caused by SRM? How do we convince people? To me, a lot of these concerns are absolutely fair, but they speak to the fact that we need to work towards robust, well agreed upon science that we can use against that, just the way we did for climate change and and the way the IPCC sort of brought the whole world together to agree upon the physical risks of climate change. I think that the same thing can and should be done for SRM so that we can potentially avert some of these societal worries.
Oh, well, one of the concerns that people bring up, actually Daniel Swain brought up last week, was termination shock. So you cool the earth, cool the earth, cool the earth. Let's say you're doing it for 20 years, and then there's a big war or something happens, and you stop putting the sulfur up in the air, and then 18 months later, it's gone. So you get all the warming you would have had if you hadn't been doing it. He thought, and I don't know where he got it from, but he thought that's way worse than accepting all the warming up until then. What are your thoughts on termination shock versus accepting all the warming for decades before such termination shock might happen? So even if it does happen, how does it compare to accepting warming for decades before you shut off SRM?
Yeah, so my bad. I forgot to talk about termination shock. So thank you for bringing it up. Let's try to think through. I would say so. Daniel is a fantastic scientist. I would say, this is an absolute fair worry. But I would say we challenge and say, well, let's think about it. So he said 20 years. I think let's think about that as an horizon, right? So currently the planet is warming at around anywhere between 1/10 and 2/10 of a degree per decade. Maybe it's accelerating, maybe it's not.
Might be 0.3 according to Hansen. Yeah.
Or it could be 0.3. Let's say that we are at a point where we the thing we agree on, the world is warming at 0.15 Celsius per decade. So over 2 decades at 0.3 Celsius. And let's say that we start doing SRM. Now, the point of doing something like SRM is that you wouldn't exactly do what Pinatubo did. You wouldn't just dump 20 million tons of sulfate all at once, right? You would start, if you agreed upon this starting, whoever is doing that, you would start on day one and you would put some stuff up. You would go on first month for 6 months. And the first few years, you wouldn't be actually doing a significant amount of cooling. We don't want that, right? The same way you don't want a termination shock, you also don't want to cool things too quick. So you would probably do that to reduce the rate of warming. And it's unlikely that over 2 decades, let's say that in 2 decades, for some reason you decide to stop or something makes you stop. I mean, I would argue that there's plenty of stuff we do that require countries to be committed to it. We have nuclear power plants and we have nuclear residual. But anyway, let's say that we decide to stop immediately. Well, in that case, yes, there would be a warming all at once of 0.3 Celsius over 2 years. That is not unlike the cooling after Pinatubo. Was it as bad? Was it as devastating as climate change? No, I would not. I would not agree with that. Would it still be a problem? Yes, of course. So SRM commits you to do something and to keep doing it. You can think about phasing it out, but not always you have those the privileges. And of course, after you've done it for a sensible amount of warming, after you started cooling alpha degree, after you started preventing further warming up to alpha degree or something, the more you go on and the more you're not actually sort of bringing emissions down, the more you are presenting yourself with that risk. Mm-hmm. But deciding what I'm not entirely sure I agree with Daniel that it would be worse than the warming in the first place, especially if you consider things like tipping points.
Right.
But it would still be a worry, right? I don't really, of course, then one has to sort of weigh trade-offs and understand if there are risks that are bigger than or smaller than. But in this case, I would say termination shock can still be a worry, and something it clearly points out to the fact that you can't just go out by yourself and start doing SRM. And even a country can't. I absolutely think that SRM would only make sense as a well thought and well planned, potentially global response. And that if one country just wanted to go out and do it, they would be way more exposed to this kind of mismanagement of risks. But on the other hand, I'm not sure that we are still at the point where we can say, oh, the termination shock would be worse than the warming in the first place, especially, again, if we consider things like abrupt potential shifts in the next 30, 50, 40 years due to tipping points.
Okay, well, speaking of things that could happen abruptly, I just was reading, we interviewed Renee Van Westen about the Amok collapse a while ago, but I see he has a new paper out saying very high probability of it occurring around the 2050 mark. And the only thing I'm aware of, and you can correct me if I'm wrong, but the only thing I'm aware of that could possibly, if we're lucky, prevent an Amok tipping point at this point, if the Amok was to tip, it's because of Greenland is melting, fresh water coming into the North Atlantic, it's slowing it down, it could shut down. Without getting into it, it's really bad if it shuts down. But refreezing the Arctic and Antarctic as well through SAI, by the way, I should say SAI, stratospheric aerosol injection, putting sulfur in the stratosphere. That's SAI. We've used that today. So doing SAI is potentially a way to prevent Amok collapse, I think. But I'd love your opinion on that.
So there's a lot of, everybody's talking about tipping points or tipping elements, if you want to make Team Lantern happy right now. I want to take a step back and say there is one thing that I think we can all agree on, and that is the fact that the main risks come from what, in finance are called gray swans or black swans, right? Things that are maybe very low probability, but whose impact would be so high that we cannot ignore them. And I think it's pretty clear that where most of those gray swans or black swans lie is in a world for which we don't have an actual analog. And that is a world with such a massive imbalance in the energy balance all at once. 1.4 watt per square meter of imbalance, as it's this year and last year, is a huge number. And so anything we can do to prevent this energy imbalance from getting worse is going to reduce risks, not just the risks we can quantify and know perfectly well, but also the risks that we physically can't quantify. And I don't think, I'm well aware of the Amok literature, and there's a lot of disagreement there, but it's okay. Disagreement is perfectly healthy. And the fact that there is disagreement doesn't mean that we should ignore that. It means that we should ask ourselves, how do we make sure that we never find out? I'm okay with never finding out whether Amok is a bifurcation point, except in models. And so this is the way I think we should think about how SRM could work. Would it avert an Amok collapse? Unclear, or I can tell you that maybe our modeling results indicate that it would, but also is not something where I particularly trust the climate models, because Amok is a particular delicate system. But on the other hand, I know that SRM is something that could prevent us from finding out whether this was a tipping point in the first place. And so anything we can do to make sure that both over the short and the long time, this energy imbalance doesn't get worse, I think would significantly reduce the risks. Now, in the long term, the only thing that prevents this energy imbalance from screwing us all up is no more increase in greenhouse gas concentration. There's no doubt that I want to say this. I know I'm always expected to say, but I actually believe it, which is SRM cannot hide all of the warming forever. It can hide some of the warming for a long time, or a lot of the warming for a short time, but not all of the warming forever. And the only thing that can do that is actually drawing down CO2 concentration. So no more emissions and carbon dioxide removal. But on the short to medium term, I think that actually the whole climate change problem is conspiring for making us less capable of dealing with climate change in the first place, because as fires increase, carbon credits through afforestation burn down, and countries use their money for costly adaptation measure rather than reducing emissions and all of that. So I do think that SRM could overall positively conspire to bring down risks in this sense, if done in a thoughtful way.
Mm-hmm. Okay. All right. I think there's going to be a lot of attention on AMOC in the next 10 years because of the risk that's growing, and we'll I think more research is needed in this area.
For sure.
So let's take a step back. Well, okay, we heard now it could work. There's certain issues that could pop up, positive and negative. But let's say we decide to do it.
Mm-hmm.
Can you maybe for the audience help us understand, practically speaking, how would we do it, and roughly how much would it cost to do it?
Yeah, I'm prefacing the fact that I'm not an aviation expert, but now I work with Doug enough to
Right.
sort of by osmosis, having learned what Doug and Wake told me all about this. So I would say, let's imagine that whatever actor decides to do it, you need to bring the stuff up there, where up there is the stratosphere. The stratosphere is anywhere above 18 kilometers at tropical and mid latitudes. It's much lower at high latitudes, at around 10, 11 kilometers, even lower. So you need to bring stuff up there. Now, problem number one, we've never needed to bring that much stuff up there. So current aviation is not particularly prepared. It never needed to bring stuff up there. So to bring aerosols all the way to the tropical stratosphere, it would take a new kind of plane with a new kind of engine, 100%. Now, on the other hand, if you decided to start it, you would probably say, well, let's start from where the threshold is lower, and that is the high latitudes. That is contentious for many other reasons, but let's just say an actor has decided to do it. It's an actor that has access to latitudes above 60 north. And so they would just go and probably use planes that currently already exist and that are able to get around 11, 12 kilometers, and maybe do the first test, large-scale test, where large-scale could mean even a ton or a few tons of sulfate. I talk about sulfate, acknowledging that one could think about other materials, but sulfate, on the other hand, is something we full well understand in terms of the environmental impact. Doesn't mean it's good, but at least it's something we understand. So you would do that and spray some stuff, and a ton or 10 tons is less than what a power plant, a coal power plant anywhere in the world emits in a day. So it's not, is it large? That depends on who's looking and who's deciding, but it is an amount that we fully well know is not an alien amount. You would do that, and then the hope would be that, of course, you would be prepared to observe what is happening with extreme accuracy, which is the main thing we're missing right now. Of course, one could take up a plane loaded with sulfate and go in the Arctic stratosphere probably in a couple of years. The question is, would we be ready to observe it? When I observe it, it means would you have satellites pointed there to tell you what is happening to the radiative balance? Currently, actually, we're about to get into the dark ages of satellite observations. There's a great paper that's coming out soon by an immense group of authors actually making this point of the fact that we are losing observational capabilities compared to 5, 10, 15 years ago. So, you would imagine that if somebody had decided to do that, they would have satellites in place, they would have observational instruments, they would have drones flying in the plume, they would have drones up and down, above and below the plume to measure the radiative forcings, look at the size distribution. That would allow us to test our climate models. test our LES, test our smaller scale model. We would observe where it goes. Then if it goes well and as we expected, which again, considering we know sulfate, I don't think that there are large surprises there. But then one would do it day 2 and day 3 and day 4 and start measuring everything from all possible angles and tracking the plume and understanding where the sulfate is going. And then we would run our models, and the models would tell us this is what would have happened if we added on it in terms of how much sea ice has recovered. We would measure the radiative imbalance. And then over time, the thing one could decide, is the thing doing what we expected it to do? Is it not? So in this frame of mind, this is what I think I meant also when I said, this has to be a global thing. This is not just a couple of guys with a balloon, but this is actually every country sharing data and sharing knowledge and a trusted source that is able to have the final say in saying, yep, we've done SAI for 1 year now. These are the results. This is how we were right. This is how we were wrong. This is why we're deciding to continue. This is why we're deciding to stop.
Okay. So I call you and I say, Dan, I just got a call from the president. The scientific research shows that the only way to prevent an AMOC collapse is implementing SRM immediately. I'm telling you, you have an unlimited budget. You're going to be part of a team with an unlimited budget to get this going. How much time are we talking about to actually, if all of a sudden we decided we want to do it? Because I think there's some people think it's going to take a decade or more. But if we were rushing, how fast do you think we could get started?
Yeah, first of all, I actually got pitched the TV show that exactly was on these premises. Not that I was meant to be the main star, but someone was like, I were on a TV show, and it sounded exactly like this. And the scientist that responds to the president says, I've been waiting for this moment all my life, which I don't think is the way you respond to the president if he has something like this. But anyway, yeah.
Okay.
So the first thing I would say, I mean, this is never going to happen, and I'm not going to get called on by the president. But the first thing I would say is that, Mr. President, if the U.S. decides to go at this alone, have you thought about the military implications of this? What will other countries do? I would not personally. I don't think I would agree unless I could convince the president that this has to be brought in front of a global audience. Would that slow down things? Maybe, but I do think that the main worry here is, have you asked other countries how would they respond? Because other countries have bombs, and so I think that would be the first thing, right? The first thing would be, okay, is this super urgent? I agree, but then let's bring this forward to the UNFCCC or to whatever other forum we think, and let's discuss this. At least we have to try that venue. And then let's say that somehow in this magic word, the president of the United States hears from me and actually agrees, and we do that, and then there's a global agreement. Of course, if there was a major rush, I think we could do things pretty quickly, but I would say that it would still take a few years, at least I would guess 5. If you think of the fact that you have to, planes they're not just laying around not doing anything. There aren't that many air bases at high latitude. There isn't a supply chain of how to bring the sulfate there. Sure, Canada does produce a lot of sulfate. There are things, maybe some things could be solved quickly, but we haven't done any of the actual engineering of how would you compress the sulfate to actually make sure that it gets released. Like, there's a lot of engineering challenges that are maybe easy, but when we say easy, we're still talking about, even if you put all of the, even in a project, and I don't want to use militaristic examples, but even in a Project Manhattan kind of way, it still takes time. You still want to do things in a way that, you're still thinking through step by step. And then, launching satellites with observational capabilities, it takes time, takes not a lot of time, but even if you were to replicate things you have, a lot of things need to be, you need to have the right launch window, and then you need to have the right equipment, and that equipment is most times custom built. So it's unlikely that it could be started even in less than 5 years, I would say. But 10 being much more likely. If you think you're in this, the word against climate change kind of scenario, if you think of, maybe starting slower, right? That's as far as I can predict. But let's say that
Okay.
I think that the more work we do right now in terms of figuring this out, the better we would be in a position to get that work done if there's ever an agreement towards doing it.
Okay.
Right. So that's
Yeah.
the main reason why you want to start now, even if you can say, do we know enough? No. And again, I might agree. I totally agree on the fact that should we start tomorrow? No, for a lot of good reasons. But the work that you do now allows you to then make decisions, make informed decisions, because the risk here is making uninformed decisions one way or another. We deploy without knowing what we're
Mhm.
doing. We don't deploy while this could actually work. These are both risks that need to be evaluated. So the
Okay.
work we do now is works that saves us time in a future where this is conceived of as happening.
So it sounds like there's a lot of things we can do now, short of actually deploying
Mm-hmm.
SRM, that will prepare us in the case that we need to use it as both an emergency thing or just as an ongoing thing. So,
Yes.
and very little. I'm speaking with Doug this was last year. I think it's changing a little bit now. There was very, very little money going into research on SRM. I'm hoping that is changing now and there are more funding sources, but still it's tiny, tiny compared to most other areas of research, right?
Yeah, I mean, I would say the situation has changed in a year, but in a way, it has changed. It has improved in many ways. I would say that for sure there's still a certain reticence for governments
Hmm.
and governmental agencies to dip their toes too much on these. Again, this is changing. Just Friday, I was in an NSF workshop where social scientists and natural scientists engaged on this topic for the whole day. Uh, God, I hope it was not a secret, but I hope not. But no, it wasn't. But so it's slowly changing, but there's definitely a lot of reticence for many, many reasons that is preventing a lot of actors from jumping in. And I would say the first one, the main reticence, is sort of the internal one from the scientific community. Now, I've talked to a lot of climate scientists, many, many people I respect a lot. And I've tried to engage on this reticence with them a lot of time, right? And understanding where they're coming from and where is this coming from. And I think it is totally understandable, right? Their first reaction to the idea of um, engaging and spending some of their research time on SRM, the reason why they don't want to do it is understandable, at least from on a human perspective. And so that is in part, I think, I have this idea, this in a way, it's my personal theory of change, which I acknowledge is very different from the one of many other people in this field, which is we don't get the scientific community, the climate science community, and the broader climate change community on board with the idea that SRM is something that is worth studying, we're never going to move this field forward. We're not going to convince, the a billionaire or a government could be throwing all of the money they want at this topic, but if the brightest mind and the most concerned people and scientists in the world are not interested in this, it's just not going to happen. The research is just not going to happen. And so, personally, what I try to do a lot of through the World Climate Research Program and GeoMIP and a lot of other things is to engage with other scientists and hear their concerns, but also say, okay, but come and do your own research in this. You don't have to believe what I say that my model says. You just use your model, do your own analysis, and then talk to NSF yourself and tell them, hey, this is important. We need to study that. So I think this is slowly changing in many, many ways. And there is a chance of sort of positive snowballing of this, where there's a broader agreement over the fact that this
Hmm.
needs to be researched. This doesn't mean that the way it's going to go, because there's as many voices saying we should never mention these and there should never
Hmm.
be an assessment of these. So that is another perspective currently in the market of ideas, I would say. Um, so yeah, I would say that's where we're at. I see this field expanding and changing and getting a lot more people on board, but there's still a lot of reticence from many actors to talk more about
So,
this.
well, let's talk about that a little bit because
Mm-hmm.
you mentioned the moral hazard that
Mhm.
if we had SRM, maybe we won't reduce our emissions enough, which to me sounds like, oh, let's let the people in the global south suffer because we need more impetus to lower our emissions. I mean, like to me, it sounds a little funny. I mean, how about have serious climate action and actually lower our emissions and not ask oil companies to pretty please do it, but actually have policy. But that's the moral hazard. You touched on that. There's also, we did a show on the trolley problem. And I think that
Mhm.
SRM is a version of the trolley problem where if we don't do it, we know many, many people will be harmed. But if we do it on purpose, then there might be a few people that are harmed, far less than will be harmed otherwise. But then it will be our fault because we took action. Do you think SRM is a
Mhm.
version of the trolley problem? Is that part of the problem?
If we viewed SRM under this light, I mean, sort of flattening out things, I would say that it would be important, and I'm not the first one to make this point, but I would say this point could be made for literally everything else. And I'll make Leon happy and say, I think in the last few years, there has been this specific case of the change in shipping emissions from the International Maritime Organization that is exactly plays out on this topic, which is the IMO decided fuels in ships should have a lot more less sulfate because sulfate is a pollutant and port cities, coastal cities are getting too much of that pollution, enough with all that sulfate. And everybody was like, yeah, sure, makes sense. The trade-off is so clear. But even in 2005, there were papers saying if you do that, there's going to be some warming produced by that. It was not a mystery. Sorry, I think 2013. And yet we did it because a lot of times in the world we make decisions when we don't have perfect information, but we're still clear enough on the idea that not acting is highly more likely to have impacts than acting, and that some trade-offs are natural. Nothing we do in the world doesn't have trade-offs.
Mhm.
I make other examples. Cooking with biomass burning versus LNGs in developing countries. One can make millions of examples of these. So, is
Mhm.
SRM a trolley problem? Isn't what isn't a trolley? I'm happy to
Okay.
be given one
What
example
isn't?
of what isn't a trolley problem in the universe, right? And trolley
Okay.
problems don't always have a clear. You don't cannot always quantify where your choice is going to take you. So
Okay. Well, speaking of it, so we are doing SRM today on a massive scale, right? Putting about 100 million tons of sulfur into the lower atmosphere. And we're doing it, quote, by accident, but we are doing it knowingly. It's not like no one knows that that's cooling the Earth. Of course, it's in the IPCC report that it cools the Earth. And we just did the experiment with shipping, as you mentioned. So I have a proposal for stratospheric aerosol injection. You and I are going to go into business. It's an advertising business, and we're going to put up big drink Coca-Cola clouds in the stratosphere made out of sulfur particles. And we're doing it for the purpose of advertising, but it might actually, as a secondary effect by accident, cool the Earth as well. But that would be okay because we're not doing it for the purpose of cooling. To me, I don't know. It's a very interesting sort of moral or ethical kinds of things where what are we doing on purpose versus not on purpose? But
yeah, and I think so. It is undeniable that SRM raises questions that are quantitatively and qualitatively different than the ones humanity has engaged with for a long while, which is this idea of actually being deliberate about modifying the environment we live in at a global scale. I
Mhm.
don't really agree or buy the point of we've been geoengineering the planet for a long time because it was always as a byproduct, right? So as you said, actually, I think yours is an interesting example of that was a byproduct. We are now developing a space industry, and that is releasing metal particles in the stratosphere. We can measure them, so it's not a mystery, right? But whether it's not like there was a global agreement, but in general, there was an understanding that people want to develop a space industry, and there might be many good reasons why one would want to do that. But that has impacts. Everything has impacts. So, but it is true in a way that these kind of discussions from an ethical perspective, we're doing something completely different. We're planning, proposing, thinking about global scale modification of the environment, which, going back to the other question, does call out the fact that let's say that we have a perfect system that is perfectly capable of telling us that extreme event didn't happen because of SRM. SRM was good at preventing that. But on the other hand, there was a drought in this other part of the world that was actually made 20% worse by SRM. If you had perfect knowledge and perfect trust and everybody believed these numbers, what would you do? Well, maybe you would think that, the people getting the impacts in the second country could be somehow, there could be some liability by the people that had decided to do it or by the whole world. And there would be some form of loss and damage kind of parametric insurance. You can call it however you want. It's not my idea. But, why wouldn't you do it? So there's, but again, this idea of doing something with the main scope of modifying the climate is bringing forth new ethical dilemmas in a way, right? And I'll just say, so there was a discussion now, I think it was 6 months ago, where some scholars told NASA that they needed to update their regulations and guidances about what would be required for a deliberate modification of climate. I don't remember the exact wording, but the current one, which is essentially what makes sense that he's doing, is you write a piece of paper to NOAA and say, hey, we're launching a balloon, 1 kilogram, cool, see ya, that's it. And the point that these scholars are making is that, well, if the modification is a deliberate modification of climate, you need to go through more regulatory steps and burdens, because the idea is the fact you're doing it deliberately. And I think that's definitely their opinion. They can do with it what they want, and they can lobby NOAA if that's what they think. But it's also so weird because if you think about it, we do a lot of things. If you drive your car with no purpose at all, and you know that it's polluting, but you just want to stick it to the libs and drive your car around, and it's a very polluting car, does that count as, if the moment we admit that polluting as a side effect is less bad than doing something deliberately, you also open up the fact that, well, fireworks don't really have a side effect except being pretty. And we know that fireworks decrease air quality over cities, mostly producing impacts on, vulnerable populations. Do you want to stop fireworks? Sure, I'm all for it. I don't care. But, the idea that you would regulate the fact that something is happening deliberately for something like pollution, where it essentially happens for most human activities, I think it's pretty dangerous and would need to be discussed a lot more. And in a way, that's what SRM does, right? It gives everyone a different perspective on humanity's role, in a way, one could say.
Well, the not paying attention is caught. Interesting. You don't think that putting 2.4 trillion tons of CO2 into the atmosphere, you don't count that as geoengineering because it wasn't done on purpose, even though it changed the entire composition of the atmosphere a tremendous amount. I mean, I guess it's a philosophical question.
It's a semantic game, right? If you define geoengineering as the IPCC did back, I don't know when, as the deliberate modification of the planet, and you define deliberate as the primary effect rather than a secondary byproduct, then no, that is not geoengineering, which doesn't mean that you're trying to shift the blame or trying to avert the blame. But clarity in the language you use, I think it's helpful, and I think that it doesn't help us to conflate the two, because we need to be much more clear-headed about what is a byproduct and what is a deliberate first-order idea and action, right? But again, it's an opinion.
Well, they're going to kill you either way, I guess. I don't know.
Yeah.
But Jim Hansen actually uses the framing of the purpose of SRM and CDR, carbon removal, is to reduce the geoengineering that we've done to the planet. Now, of course, he's not using the definition you just used, but I think that's an interesting framing. Maybe just on this point, you said you've talked to many, many climate scientists about this subject. And I know Michael Mann is opposed. There's many of them are.
I haven't talked to him.
SRM.
I mean, he doesn't want to talk to me, so that's more
okay. Well, or to a lot of it. We did have him on. What would you say the top two or three objections are from the climate science community that you've spoken to against doing SRM?
Yeah. So there's one that I cannot say live, but I'll tell you once this call is over, I promise, because it's funny. But okay, so the serious one. Um, so the first reaction, and I don't just not just climate scientists, but also ecologists, environmental scientists that I talk to and
Okay.
I work with. The first reaction is, "Wow, that's nuts." If they haven't heard about it before, the first reaction is, "God, that's just nuts. Why are you even talking about this?" Right? And I
Okay.
think that that is not to be made fun of, in the sense that do need to acknowledge that that's how most people are always going to react to the idea of global scale deliberate modification of the environment we live in. And so this kind of gut reaction, it is the one that most people have. I mean, I would say it's the healthy one. To cite my friend Andy Parker, it's a pretty crazy world where we think that doing SRM is less crazy than not doing it. But so this is the first gut one, and I think it's relevant. And a lot of times, when you have a gut reaction to something, then you will try to rationalize the reason behind your opposition
Ah,
and
okay.
come up with them, right? And so if you don't, as an example, people have said for a long time, are oppositions to vaccines sort of roundabout way for people to say that they're just scared of needles? And would vaccine acceptance rates change if they are nasal sprays? And it looks like it
Yeah.
is one of the cases, right? And
Oh,
I think that SRM could be really one of the same things, as seen where the first gut's reaction of being terrified of the thought is actually a healthy one, but then people rationalize their opposition based on that. Now, that's the
okay.
first one. The second one, I would say that climate scientists across the board see it as their job, or the way that climate science has been politicized by not by climate scientists, I would say, to begin with, but climate scientists see it as their job not just to publish papers and do analysis and talk about risks from a scientific perspective, but also to talk to the public, warn the public, warn policymakers, and convince policymakers about specific course when it comes to climate policy. Um, to me, that's normal, right? In a way, I do agree that it's pretty hard not to be. And if you see that there's a gigantic risk coming towards you, you don't just want to say, "Hey, there is that risk." You also want to, sort of shout at people and tell them, "Oh, do something, and this is what you could do," right? I wish that that same observation was afforded to SRM scientists, as in that people didn't think that people that research SRM are activists because they have some nefarious purpose, but it's just because they're as worried as they are. And so that's the way they think that this could be, in a way, part of the risks be averted. So there's this thing, right? But people think about moral hazard along those lines. If we tell people that there is something we could do that could reduce risk, would that sort of undermine our message that we need to reduce emissions? I'm just not going to give a judgment on that, but I would just say that is sort of the main thing, right?
Okay.
So there's one, and then of course there's the other one that is sort of connected to that but different, which is this is not about power relationships between people or people and climate scientists, but this is again about governments and countries, and would countries behave differently if posed in front of the topic of SRM? I would say that, having now had the privilege and burden to talk to a few representative of countries, I would say that they are way more terrified than even scientists or people. They really don't want to talk about SRM if they could help it.
Oh, really?
But on the other hand, they're starting to ask, like, well, but is this a thing? Like, is this something we should pay attention to? And people are worried that there is a risk that countries would change their behavior, they would stop cooperating on climate policy, that they would be less serious. Now, the counterfactual to that is the fact that, well, countries are already doing whatever they want pretty independently of whatever they pledged on for the Paris Agreement, or in terms of national determined contributions. And so
Hmm.
it is pretty hard to imagine a world in which they do even worse than they're doing now. Maybe not, but that's clearly. But on the other hand, the other point is about power relationships, as in there are a few countries right now, don't need to name them, but of course the US is probably the main one, that essentially wield power over the international order, and they're not always fair about it. And so, would adding another weapon to their arsenal, something like SRM, make this whole international mess worse? I'm just channeling what a lot of people tell me, right? But I'm
Sure.
responding
Then
to
the
these,
question is,
and
what
so
happens
I
if you
think it's a
don't
very
do it?
fair one. Right.
Yeah.
The question is, though, on the other
How
hand,
does
people
that
are
affect
talking more and more
international
about,
relations?
Mhm. And people are talking more and more about sort of societal tipping points. Would panic about climate change make climate change
Exactly.
policy worse? Right. People are panicking
Right.
and people are asking to declare a climate emergency. I think sometimes without actually being explicit about what does it mean for them, and how do you engage with the fact that countries don't usually fare very well when they're given too much way over democracy, and so emergential responses are always undemocratic, and this is like
Mm.
almost always undemocratic. And so this worries me a lot, and so I would say I would that there's also the other possibility, which is to say that if we communicate, and again, I understand that this is putting a lot of power on climate scientists that many people don't think we have, but I would say that the most honest thing would be to say this is SRM, this is what it does. I don't think that there's any point hiding behind the fact that we actually think that from a physical point of view it would work, but also that if you do this wrong, this is going to be problematic, right? And so here's
Sure.
a sort of scientific blueprint about how it could be done well. And then, of course, the decision is not up to the scientist. The decision will never be up to the scientist to do or not SRM. And people can do with knowledge whatever they wish. But I think that people can do without knowledge even worse. So to me, the
Mm.
main argument for the people that are worried, the scientists that are worried, is to say, yeah, I see, I hear you. It's fair to be worried about this topic,
Sure.
but people will do this anyway. I'm sorry, but I would say that
Mm.
people will keep talking about this. And I'm starting to hear more and more people actually ask me the opposite question, which is, why aren't you talking enough about SRM? I was actually taken
Right.
aback in a couple of recent interviews with journalists. I was like, why is this topic not talked about more? And I say, well, I publish paper all the time, but no, I get that that's not the same thing. And people will, as communication shifts to, there are these tipping points and they're imminent. And to quote the paper that came out from a large group of climate scientists recently, we are on the brink of disaster. I don't think you can keep telling people for forever that they're on the brink of disaster and then in the same paper dismiss SRM as, but we shouldn't talk about SRM too much because it has its own dangers. Well, at one point you need to be honest and say one risk is higher than the other. And I would challenge those people to demonstrate to me and to devote their brain power to demonstrate that SRM is riskier than climate change from a purely physical perspective. That's
It's hard
actually
to
how
imagine.
many people. That's how actually how almost everyone I know got into SRM. As in, even me. Like when I was doing my PhD, I
Mm.
was like, "Oh, I'm just gonna find the chemical pathway that shows that SRM, that SAI is devastatingly bad." And then you try, and then you're like, "Well, actually, this shows that there's like 100 versus 1 in terms of risks." And then like, okay, let's look at something else. I've looked tons of things and worked with many scientists, and then eventually you're like, well, okay, so maybe this is more nuanced than I expected. And then you have to grapple with the thought of, well, what if this thing now it's not as bad as I thought it was going to be? Do I keep pushing on, ignoring the goods and just focus on the risks, which is what a lot of people who prepare fair was
Do.
done with SRM? Or
Yeah.
do I give a balanced view and let people decide for themselves?
Well, that's, by the way, okay. You're getting to, I think, to the essence of the question, and that is anyone who says, look at SRM, it has all these negative side effects. You can't say that without also looking at the risks and side effects of not doing SRM. I mean, because we don't have a status quo world where everything will be like it used to be. We're putting more greenhouse gases in the atmosphere at a record
Right.
rate, and it's getting warmer. So, do you have a feel? I mean, to me, I just say the risk of not doing it, to me, just personally, I feel is an order of magnitude or more worse than doing it. Do you have any numbers or some kind of measure of how much worse two and a half, 3 degrees of warming is versus a world where we're doing SRM and you have some side effects?
That is a very tough question, and I know where David's number, the ones you mentioned, come from, and I would say that those, in a way, if you're sort of thinking about deaths from increased climate extremes and especially heat waves versus changes in air pollution, I think David's number sort of hold up pretty well, quite well. He'll be pleased to hear that I agree with him. Almost never happens, but
You're talking about David Keith, right?
Yeah, I mean David Keith.
And what is his number? I'm not sure of his number. What
I
is his
think
number?
his number that he quoted to you. I think you said earlier today was that, you know,
1,000 to
1,000 to 1.
1. No, that was just for health impacts
Yeah, for the health impacts. That's
of
what I'm saying.
accidental
That's what
SRM
yes,
versus purposeful.
yes.
That's not
Yeah,
climate.
yeah. No. That's sort of, yeah, and that in a way is, but in a way, you know, you can make the same argument and say how many people are projected to die because of increased heat waves. Now, of course, when you make those kind of questions, the problem is that you're always implying, are people going to adapt or not adapt? Is this all else being equal with no changes in adaptation? And then you can ask, but is adaptation infinite? You know, I think that we'll never. So this is all to say, you're never going to be able to actually come up with a credible number that is holistic in nature. But that is because even if I ask that about just climate change, there are big differences if, again, you say 2.5 degrees. Well, but are we considering tipping points or not? Because tipping points are not really considered in AR6, but also a lot of them, I would say, are in many ways unquantifiable. As in, how many people would be impacted by an Amok collapse? I don't know. That depends how abrupt it is. Is it as bad? Everyone. But, you know, would we adapt to that? Would we not be able to adapt to that? Would that essentially lead to the whole UK moving to France and lead to the second War of the Roses? I mean, there can be, you know, there like when you're trying, you don't necessarily. There's a lot of good reasons why you need to quantify this, and I think again that David's example is one of them, but not all the time can you perfectly quantify risks.
Oh, sure.
Yeah. Risk, and you can't for climate change, which is a thing that was used, which was a talking point that was used by climate change deniers for a long time. We knew climate change physics well before we had satellites in place to measure it. And yet we waited the IPCC waited a lot of time before they explicitly said, you know, it's virtually certain that climate change is human-made in nature. Mm-hmm. This is right, and the reason was that for a lot of time we're like, well, I don't know, maybe climate sensitivity is small, maybe Richard Leadson was right, and the iris effect was correct. It never was. It turned out not to be. But you know, there are a lot of examples of things you can say. Maybe it's not going to be as bad as it is. Maybe it's going to be as worse than it is. And eventually, things that you need to quantify, also including uncertainties. And epistemically speaking, uncertainties are up to a point unquantifiable, and so you need to make a decision based on that level of that degree of not knowing, right? Okay. And so this is why I resist the urge to put numbers to it, even though we can put numbers to specific things and say, look, do we have climate model simulations that show that extreme events across the board in essentially 95% of the world would be less than with SRM than with climate change, even in a 5 degrees world? Sure. Does that mean that that's the reason why we would? Is that the reason I would use to advocate for more SRM research? Not necessarily. I think that there's much worse in all the nonlinearities that the climate models can't capture, and sure, those might exist for SRM as well. But I think that we have actually some more robust understanding of the upper bound of what happens if you put 20 tons of sulfate all at once in the stratosphere than we do for what happens if we have an imbalance, a growing energy imbalance over 100 years. And so to me, that is the main reason. The main reason is that we will be virtually better off with less energy imbalance than with more energy imbalance. And SRM could be the only bridge. And SRM will be the only, it's very likely to be the only bridge for the next 50 years, they could sensibly prevent the energy imbalance from getting worse while we develop a lot of other things and while climate policy catches up.
Okay. Well, I have a million more questions for you, but we also have some other people want to ask you questions. Uh, Fascinating discussion, and sure, this is going to be something we're going to talk a lot more. I'm going to welcome Stacy, our co-mod. And Stacy, what's your question for Dan?
Hi. Well, I
Hi,
also,
Stacey.
hi, Danielle.
No,
I also wanted to high five on your love of trains. I am a big, my whole thing is transportation and getting people to move differently. So, um, high five on that. I have just a very few quick hit, clarification questions about things you mentioned. You said that global sharing of data and standardization is something that I'm assuming standardization is something that we should have in place and that we would want if we were going to do that. Does that not already exist?
No, no, absolutely not. It's actually surprising when you see how piecemeal the whole thing is. I'll give you two examples, right? One, going back to the IMO regulation, it's 2024. The thing happened in 2020, what it was planned 7 years before, is not like we thought about observing that carefully or doing modeling studies right after that to evaluate what happened. The other one is the Hunga Tonga eruption happened now almost 2 years ago. And we are right now, 2 years later, about to submit the modeling paper about the protocols to follow to do the modeling to understand what Hunga Tonga did to the climate. I know it's bad, but there are good reasons for that, and the main reason is the fact that the current scientific environment is not really built to do things on a fast response. And the same thing applies to sharing. If the challenge that I can give to you, because it's the one that one of my postdocs is currently going through, is you try to plot Calypso data from 10 years ago now about the polar stratospheric clouds in the Arctic. Good luck. They're still on essentially ungraded data coming directly from the satellites. Nobody has made available fully all of the data in a way that is easy to visualize. So these are all challenges where when global South countries tell us that they don't feel included in SRM research, that's exactly what they mean. And I work with a lot of them. And so I talk with first-person experience where I have to go to meetings with them with hard drives because it's easier for them than downloading stuff. And of course, they don't have access to data. We basically built the whole infrastructure around a bunch of very high-tech, rich universities in Germany, UK, and in the US. And if we don't change that, all of this is going to become more and more challenging.
So there isn't like a central access point that, people who are vetted could tap into?
No. Every agency has their own satellite with their own data sharing things, and sometimes you need to register, sometimes you don't, sometimes you have to directly ask access to data. The data that underlies the IPCC report is public, but I would challenge, and again, I know this because my grad students have problems when they start. I would challenge you to go on the Earth System Grid Federation and download surface area temperature for a bunch of models and plot that in less than 3 days. So no, the answer is we don't.
So you have two things that the other you mentioned that we are losing satellite viewing capability. Do you mean governmental satellites? Because we're putting stuff up there nonstop, I thought.
Right. And now there's the example where EDF is a new satellite looking at methane emissions. So we have the technology, we can build the things that we think are necessary, but this clearly doesn't apply to the stratosphere, where we are losing capabilities. I could name you names, but essentially most of the satellites, there's a figure that is again about to come out in this paper, led by a lot of very important stratospheric scientists, essentially saying we're about to enter a desert of information when it comes to the stratosphere. How on earth would you even talk about SRM? And I think they're right. How on earth can you think about talking about SRM and SAI if you can't monitor even something as basic as stratospheric water vapor? And part of that is because, in a way, people were like, oh, we've solved the ozone problem. It's fine. We can go back to ignoring the stratosphere. And so these might change. But currently, currently governments are actually not that interested in observing the stratosphere any longer.
Okay.
And then
Any
the last
final
one
questions?
is compute. You mentioned about being able to process that, download the surface temperature and do that within 3 days. I mean, that seems like more of a bandwidth problem, but compute, should the tech industry be donating compute power, and can AI help with the modeling and scenarios?
So on the first part, I would say yes, absolutely. And I've personally talked to a lot of people. And again, there's a lot of reticence to actually be seen as supporting SRM research. But yes, I wish we actually had a lot more of that. And me and a lot of other incredible people are working hard, I think, on doing that. On the AI part, I would say that, again, the main problem that we're talking about here, though, is with trust. And while AI has a lot of applications, even fantastic one for weather forecast, I think we're still way off when it comes to climate. And if the question is why should people trust us when we say things about the climate impacts of SAI, well, try to get people to trust the machine learning telling them about SAI. So I know, I think that that's a lot more nuanced. People could say that's because I'm stupid and I don't understand machine learning, but there's that. Like whatever we do on this field, we need to be able to ask. We need to always first ask the question of, yeah, but will people trust what we say, right? Will people trust the observation we send in? And think about the disinformation after the hurricane or after the flooding in the Middle East that people blamed on cloud seeding, right? The fact that you as a scientist know that you're right doesn't mean that people will believe you. And so there is this societal level to climate, to data sharing that cannot be ignored.
Okay, very good.
Thank you.
Thanks. And Eli, so one of our co-mods, Eli, he also actually works on space-based SRM. But Eli, do you have a question for Dan?
So three of them. The last two will be quick, but they're set up by the first, which is a little involved. In the past, GeoMIP appears to have emphasized 4x CO2 and SSP scenarios, the IPCC scenarios. As 2023 and 2024 have shown, the impacts of climate disruption can take us by surprise, and have that noticeably increased the appetite for SRM. So earlier starts than have been modeled are probably not inconceivable. Among those who studied space-based SRM, that's also generally regarded as a far-off prospect, despite the fact that on reappraisal, it's actually less costly than SAI and more short-term feasible than generally appreciated, which may also be true for other SRM modalities. Just a quick point on space-based SRM. It reduces atmospheric chemistry and interactions and termination risks and permits dynamic spatiotemporal and some spectral control. Is there any effort to broaden GeoMIP scenarios and intervention modalities so that we can take on these sorts of approaches?
That is both the long and the two short questions, or
that's the long question, the long one, and the two short ones.
So, okay, I'll say, well, for people who don't know, climate modelers, a lot of time, so getting climate models to agree on stuff is like herding cats, but sometimes it's fun, but that's what it is. And so there are a lot of these model intercomparison projects that are essentially groups of scientists that get together and decide on stuff to run together and to make the experiments as similar as possible to compare across the board. GeoMIP is one of them for geoengineering. We meet once a year in person. There's normally a lot of people now, a lot of scientists also from the global south coming to the meetings. And we talk a lot about what scenarios to simulate altogether, and also what are our duties when it comes to communicating the scenarios that we're deciding on. And there's a lot of decisions that come that are driven by what we can do with a climate model versus what we would like to do, but it's easy to do in a multi-model intercomparison perspective. So there's a lot of these decisions, and I would urge anyone where I'm actually, I always publish the meeting reports where we always outline these discussions, and anytime now that we've published the protocols for new experiments, I actually made a point of detailing why we're making every single choice we were making. One of them being, this is for the next set of simulations, why did we decided to use middle of the road emission scenario, and why we decided to start SAI in the simulation in 2035. So we were very explicit about that, and also, for instance, in that paper and in previous ones, we were, since we have a lot of expertise in the room, also when it comes to MCB, we also had very clear explanation about what are the challenges to deciding on a multi-model experiment of MCB that comes from the fact that what do you do in the climate model, where do you do the MCB, and there's a lot of incredibly smart people that are looking at that, and probably we will have a protocol for MCB multi-model simulation soon. Now, doable, but it's a lot harder than it sounds. Now, space-based, well, first of all, I would say I'm friend with Ross and the other people that do space-based stuff as well. We chatted just like a couple of weeks ago, I think. First of all, in a way, the 4 times CO2 stuff, I would say that's for science, right? And I think it's actually helpful to explain to people why you're doing some things and not other. And sometimes you do scientific experiments that are not meant to be policy relevant, but we just need to understand stuff about climate dynamics. And we should keep doing that. We cannot be expected as climate scientists only to do stuff that is immediately policy relevant. There's a lot of merit into just doing more basic science. Hey, I was the first, I have papers back from 2021 where I simulated solar reductions across more complex latitudinal and seasonal patterns. So you're not telling me anything new, and Doug did as well before me. The point again being, first of all, you can just convince climate modelers. If they had infinite time and space, you could convince them to do literally anything you wanted them to do. But we don't, and we're constrained by resources that are for also other things like climate change modeling, so we can't do infinite things. But if you think that you have a better idea than the ones that the GeoMIP community already has, come to the meetings. They're public. The meeting reports are public. Write an email to me and Alan Roebuck, who are the co-chairs, and to the steering committee if you have better ideas. I have plenty of papers detailing what are the pathways by which experiments are proposed, described, and carried out and analyzed. And so just do it. We're the opposite of a cabal. We are actually super open and always welcoming to other people.
So, any short follow-up?
Yeah, I'll combine the last two. There are these things called emulators that try to reduce the computational complexity based of modeling things or considering scenarios based on the results of much more higher fidelity models that are more costly. Are there any efforts to make these available to the public for GeoMIP? The reason I'm asking is that this would, engage more of the public and get people to think about SRM. And I will also mention that we've had Will Wright as a guest and discussed gamifying climate scenarios. An emulator as part of that could, I think, be rocket fuel to public engagement, and also perhaps break some of the learned helplessness that attaches to climate. Your thoughts?
Well, yeah, thank you, Ella. People will absolutely suspect that I set you up for this question. Here's my answer. Probably in a month or so, when I mean me and sort of a group led by Dakota Gruner, which is a nonprofit in this space, we will release a web-based emulator based on climate model simulations. At the last GeoMIP meeting, we discussed a lot the topic of emulators, and so the meeting report is going to come out soon. We'll have stuff about that. Part of our group at Cornell is developing an emulator. There's actually a paper that is already published, and there's another one. My student, I showed some of his results at Harvard 2 days ago, and people were pretty excited about that. So there's a lot of things we're doing, and I'm just saying what I'm doing, but a lot of other people are doing stuff as well. Now, I was very skeptical for a long time about exactly the points you raised about sort of both the gamifying and the simplifying and the giving this tool to the public. And even when we were testing this new emulator tool that is about to be released, a lot of the feedback was like, are you sure you want to do this? The main reason behind it is the fact that when you have something like an emulator, you are all the time collapsing uncertainties into a final product where most of the uncertainties are by definition swept under the rug and collapsed one onto the other. So if you're not careful about that, and if you're not careful with communication, people will accuse you, and it will be in a way fair to say you're presenting this topic as much more certain or much more smooth than what it is. So for instance, as an example, the version that we're releasing sort of only allows you to sort of think about different temperature targets and different release dates. But the version that our grad student is releasing is working on also has different injection locations so that people can think about different political scenarios. But all of this work requires making decisions about what uncertainties to consider and what not to consider. Now, for a long time, this for me was reason enough not to actually spend too much time on this. And I think a lot of people still think that's the case, and we shouldn't. But on the other hand, I think I've grown wary enough of the opposite thing, which is to say, oh, this issue is too complicated for you, the public. Let me tell you what to think. And that actually there is some merit into having these hard discussions and letting people think about it while taking control of that, if it is intended as a way to start the conversation and not to close it. As in, it is not intended to say, this is SAI, this is how cool it's going to be, please buy our product. But rather, okay, there's this thing. And honestly, this is what our models tell us. And if you want to read more, here's this long document we put together with all the question marks, but let's start having this conversation. And this is the way I'm thinking about emulators a lot more. And I hope that pretty soon we can shift this conversation and turn it around on these. And yeah, I'll show you the results. You'll be able to see them soon.
Very good. Well, thank you, Eli. And next question will be from Leon Simons. Leon, do you have a question for Dan? You're welcome to come on. Great.
Hi, Danielle. Good to see you. I have two questions, one short one, but maybe your answer will be long, about conflating the effects of sulfur emission changes, like unintentional change in sulfur emissions, and SRM. And of course, you've done research yourself on SRM, you've done research on the effects on shipping emissions, the unintentional changes, let's say, with regards to climate from shipping emissions. And maybe from your own perspective, how is there any problem in between these for yourself and doing this research? I think also what I've seen a lot myself when we are publishing about this, and I've seen it happen with you as well, that others are conflating this, that they say, okay, you're doing this research, but you're making it worse than it is, or you're trying. We don't talk about the intentional sulfur emissions because people might talk about SRM. So maybe you can elaborate a bit on that.
There was in the paper that I cited from 2013, that's exactly what they explicitly said. At one point in the conclusions, they say, we've shown that it would have a great impact on air quality, this IMO change. And sure, we could have also simulated the effect of not turning on the scrubbers over the deep ocean where nobody lives, but that would be akin to geoengineering, and we don't talk about that, which in 2013 was a lot everybody's vibes. And on the other hand, I would say that I've also talked to people who told me that philanthropies have recently become very wary of talking about black carbon reduction because they feel like they've heard too much about how sulfate actually was hiding the warming and how hurricanes were actually produced by the IMO change. So it is true that we need to be careful in how we communicate that, right? And so I think that I have to say, actually, the scientific conversation has been balanced enough. There clearly emotions are running a bit high, but it's been, I think, fair, and I've learned a lot from it. They are two very different topics. I would not conflate them too much. They're only similar insofar to me as they make us think about the idea of what it means to do something deliberately and with good information. And look, people, whatever you do, people are going to say that you're doing this because you're a proponent of geoengineering. Maybe 4 years ago, I was much more worried about this and be like, no, we're actually just doing this out of scientific curiosity. At this point, I'm like, yeah, that's what I do. That's the research I do. I think it's important. If you don't think it is, go do your own stuff. Just leave me alone to do my own. And you want to publish your books where you say that we're evil, whatever.
No,
You got another question,
I think
Leon?
that's a healthy approach, especially for your own mental health. Sorry.
Yeah, absolutely. Oh, yeah.
Yeah. So the other one is you said SRM should done in a thoughtful way, and I think that's that you could there's a lot behind that, right? So now there's in the media, or in at least on social media, there's a bit of a bit of noise about the Amok again, because there's this new study, I think it's still a preprint, where they say it's 95% likely that the Amok will collapse before 2050. And if you look at the other reanalysis data they use, it's even 90% likely that it will collapse before 2050. And this then I talked to one of these authors, and what he said was, if we would like to say, for example, the Amok, we should implement geoengineering as soon as possible. So then, if you are thoughtful and you want to the Amok not to shut down, you would have to do SRM as soon as possible. At least that's like my objective reading of this. And then you see other studies showing that if you do marine cloud brightening over the mid latitudes, the Amok will strengthen by about 0.2 petawatts, right? Or we did the opposite. I think that's in a way there's a. Well, I use this question for the second one, because otherwise I would, in a way it answers already the first question I was asking, like, should we do it on purpose or not? And Dan said, if you have all the money in the world, but we do this almost for free, right? Do it on purpose, like you said, what the 2013 paper said. Oh, if you do it over the offshore, then you could have a similar cooling effect without the health impacts.
Yeah, so I guess if the question is, should we be advocating to do SRM now? Is that the question?
Yeah, I'm just thinking out loud. Like, what does this mean, right? If this is true, so if the science shows that without this, the Amok will shut down within 25 years. Within 25 years, some maybe even it's already shutting down, right? Because we reduced the sulfur emissions over the northern hemisphere mid latitudes already by 80% in 2020, as you very well know. So we've done the opposite. We caused it to slow down faster than it would have otherwise have done. So what does this mean? What does it mean that the science shows that we are causing the Amok to slow down more rapidly? So what does that bring?
Okay, what I can say is that I want to focus on one phrase you use, which is the science shows, right? And science is actually very complicated, even from a societal point of view, about what does it mean. As in, what does it mean if 1, 2, 5, or 10 studies show one thing, and then another 5 show another thing, or maybe studies are inconclusive? Science can change, and our a priorities can update as we get more information. There are also studies pointing out the fact that in their observational record, actually, there isn't such a there are unclear signs over the magnitude of the Amok slowdown, and we, for instance, don't know for certain that Amok has a bifurcation point, and so it
Really?
will collapse, as in it's a possibility. There are plenty of suggestions that it has in the past, but paleoclimate people are always very careful in saying the fact that something has happened one way in the past doesn't mean that due to changes in ocean currents or due to changes in the way continents are placed together, it doesn't mean that it will now. So this is all to say, and the paradox of all of this is this, right? That this is not, I'm sorry, but this is not like an asteroid coming our way that we can see and observe and we can predict astronomical motion very precisely. The climate system is messy, and it may be that Amok has a chance of collapsing in the next 25 years, which, by the way, tipping points are not really that big. They're not that narrow of a point. So this probably would indicate the fact that Amok has already started a collapse. It's not something that is going to happen from one year to the other. Well, we don't know whether it will. And one could make other examples of elements of the climate system that are accelerating their change. And that doesn't mean that they're tipping, in the sense that it doesn't mean that there are hysteresis points in the system. It doesn't mean that there can be no recovery whatsoever, because that's what technically, once upon a time, a tipping point meant. An hysteresis point of the system where then you need a forcing that is much larger than the original forcing to bring it back to the state it was before. We just don't really know. And again, the point is, since we don't know, we're better not find out. So the point of thinking about SRM is not to say we should do it now because the Amok will collapse, but it's to say it might be worth thinking about preventing further imbalances of the energy system, because if we don't, the uncertainties over some elements like Amok might become unmanageable, and then we might find ourselves in a position we don't want to be.
It's like a precautionary principle here. Like, by the way, I always find it fascinating that we're talking about these things that have much, much higher probabilities of utter disaster compared to an airplane crashing, which, if it was beyond 0.01% crashing, we would do everything we wouldn't fly the plane, we would ground it and fix it first. Yet the study that Leon was quoting said under some models it was 90%, but under some other basic model, it's still 60% chance of shutting down by 2050, which is, if it's 1%, we should be taking urgent action to at least understand it better, and we're not.
And I think that's based on reanalysis data. So that's what's already happening indeed.
Yeah. We have, by the way,
but reanalysis are models. They're not observation, and there's plenty of things that one can point in reanalysis where they don't do great, which doesn't mean that we shouldn't use them. But reanalysis come with their own problems, and one of them is that you don't actually have ways to nudge the deep ocean. So the dynamics of the deep ocean in a reanalysis, somebody's going to send me hate mail about this, but might have large uncertainties as well. But we know that reanalysis has problems with precipitation in many locations, so reanalysis is not perfect.
Yeah.
But the fact that reanalysis are not perfect,
they use 3 different reanalysis products, and that's what's quoting.
But you see, what we can agree on is, even if just one reanalysis showed that, we should be discussing and understanding it way better. What I'm saying is that, would I make a bet over Amok collapsing in 2049? No, because I don't bet that way. I think it's stupid. But on the other hand, the suggestion that there could be a risk like that should be enough to warrant way more research than the one we're currently doing.
Right.
And way more caution over climate change in general.
And for anyone listening to this who wants more information on Amok, we've done interviews with Peter Divletson, who has one method of looking at it, Renee Van Westen, who has the recent paper as well, and then as well Jim Hansen, who looks at it really from a physical modeling point of view, or saying that IPCC is not their ocean mixing isn't right, and therefore the fresh water actually has a bigger impact than they assume. So anyway, there's a lot of different ways of looking at it, and all the new information is at least scary. I think it's a safe thing to say. And it's interesting how these two subjects, Amok collapse, which is getting a lot more attention recently, is tied in with SRM, which is also getting a lot more attention. Dan, I want to thank you for spending this time with us today. Again, I have a million more questions. We could talk for another hour or two, as is usually the case here on Climate Chat. but an hour and a half is probably pretty good. And thank you so much, not only for
Thank you
spending
for
the
having me.
time, but also thanks for the work you're doing, and also for the outreach that you do. Because we met at Climate Week when you were there, and this is very important to get the word out on what it all means. And you did a great job explaining things. I learned a lot today as well. I hope that everyone listening did as well. So thanks. Next week,
Thank
by
you.
the way, for everyone listening, we have Saul Griffith, who's well known about electrifying everything. That'll be next Sunday at 10 a.m. Pacific time. Please subscribe. Please like the video so it gets shown to more people. You can follow me and follow Dan on Twitter and other platforms. Look in the description for links there. There's a link to his web pages as well if you want to learn more about the work he's doing. So thank you again. And everyone, we'll see you next time. Thanks for
See you.